Hello, and welcome to the Hydrogen from Water video. This video will show you how to use ultrasound and zinc oxide mesoglass to produce hydrogen from water. The ultrasound is at 43,000 CPS, the Keeley water dissociation frequency, and it is used to break up the water in conjunction with the zinc oxide. The zinc oxide, here shown, is in the form of a cone. This conical zinc oxide within the glass vessel has been specially treated. Coming in a zinc mesh sheet, it was heated up in the presence of oxygen gas produced by hydrogen peroxide, the oxygen bonding with the zinc making zinc oxide. This zinc oxide was taken and formed into a conical mesh. Afterwards, more of the bits and pieces from the zinc mesh were inserted inside the cone. This will create a very interesting phenomenon called Anderson localization. In Anderson localization, the disordered components in the zinc oxide mesoglass break up the ultrasound waves into a disordered cacophony. This disordered cacophony produces regions of intense concentrated sound. These phonons in the sound then rip apart and tear the water molecules, shredding the water much easier than is done in conventional electrolysis. We will now add to this solution the water. The ultrasound has been turned on, and as the water pours into the vessel, the ultrasound already filling the chamber will produce bubbles and viscous action. The viscous action will also help the Anderson localization. Bubbles already forming due to the fucking catalyst. The reaction is starting off slowly, but as you can see, the zinc oxide bubbles are forming into the mesh. Soon what will happen is this thing will start bubbling much more ferociously once the reaction gets underway, and as the bubbles generated from the zinc oxide catalyst flow up, they'll be collected in a vessel, which I have decided for the ease and simplicity to make a balloon, and this balloon will fill with hydrogen gas. We'll give you a closer view so you can see some of the bubbles already starting to form. Soon this reaction will become much more intense, more bubbles, more reaction, but you can already see initially the bubbles forming. In order to test for the presence of hydrogen gas, we have over here the best test for hydrogen, the kaboom test. These candles are ready and waiting for the balloon to be formed, at which point the balloon will be passed over the candles, thus igniting the hydrogen gas. Bubbles are already starting more intensely. It's forming at the top region. Should be ready soon. Here are our reaction vessels. The reaction vessels ready to collect as soon as this thing gets going. A little more. It's unusually slow today. The reaction finally is taking hold. Once the reaction firmly takes hold, we will be attaching the balloon reservoir so that the hydrogen bubble gas can be collected and extracted. The balloon reservoir has now been attached. impatient with the thing to actually work, we've decided to move this up a bit. This should create a pop or a loud noise as soon as it touches the flame. And this is why we have two candles. Holy! As you can see, no real popping sound, but the gas has exploded out the side of the balloon, creating a tear and a hole. The unit you see here is a preamplifier. The preamplifier was gutted of its original components. Batteries were placed in, capacitors were altered, and some other stuff. A fairly conventional speaker was used, as you can see here, quite badly. The speaker being able to produce sounds from anywhere between, I guess, 20,000 kilohertz and up to 60,000 kilohertz. It's been set here to play out at 43,000 CPS or kilohertz. That is all.